with code generation is meant the translation from intermediate representation instructions to machine instructions. And there are two compulsory parts, namely first to select which instructions should be used, and also for modern architectures, I mean RISC, then also register allocation is necessary. If optimization is used, we also do instruction scheduling. In LLVM, the intermediate representation instructions, one or more such, is translated to one or more machine instructions. And to do this, directed acyclic graph called the selection DAG is constructed. The nodes are instructions and the edges are the data dependencies between the instructions. Then a matching is done, and this DAG is transformed to, well, it's still a DAG, and the nodes now are machine instructions. The types are in the code generation directory, selection DAG and selection DAG nodes. And clearly the libtarget subdirectories are used to see which machine instructions are available. Okay, instruction scheduling. It continues on the selection DAG and schedules instructions from it. And before register allocation, there can be different instruction scheduling algorithms, but after register allocation, if it's needed to do another schedule, then list scheduling is used. And each CPU architecture has its own default scheduler. Register allocation in LLVM. First, we will not go into the details of this, since the focus of the course is to study the state-of-the-art register allocation based on Chaitin's algorithm and iterated register coalescing. But we will anyway do some observations. First of all, there is a faster register allocation algorithm called linear scan. It was used in LLVM before LLVM 3, and what it does is to scan one basic block at a time to see which registers are used and do suitable things when when different basic blocks are joined, or at the edges in the control flow graph. Okay, there are some remarks from an LLVM developer when the new register allocation algorithm was introduced to LLVM. These are not his, but they are quotations from other persons in his talk. And although conceptually linear scan appears to be a very trivial algorithm, there was a need to clean up the code. And it's not linear because there are many different things to do. And there is really a lot of bookkeeping to make sure that all data is up to date, etc. So what they wanted was a better register allocator. And there are different alternatives. First, there is one which works at the basic block level, and then there are two which are not too different from each other, basic and greedy. And this one, the basic, the focus is, well, the effect is to assign small live ranges first. But that's not always the best idea, because the large live ranges may be better to assign first. Okay, so there are these two alternatives. And then there is, but for the course, don't bother about the register allocation in LLVM. And then for very irregular architectures, for instance, for DSP processors, there is an algorithm based on partition Boolean quadratic programming. And it can achieve better performance than the others for these irregular machines. There are also many different research studies on other forms of register allocation. But we will not dig into those at all.